In this section of the textbook, we talk about ions and what the electron configuration is for an ion. So groups 1, 2, and 3A, which are the main group metals, we already know they form a charge equal to that of the group. So sodium, which has the core electrons of neon and then has a 3s1, because it's in group 1A, becomes a +1. And so what it does is it loses the 3s1. Magnesium is the next element, and it's neon base with a 3s2. So magnesium is in group, so this is 1A, this is 2A, and so therefore has 2 valence electrons. It loses both of those electrons, so it loses the 3s2. And aluminum is column 3A, and so it has 2 3-valence electrons. It becomes aluminum 3+. So again, it loses the 3s2 and the 3p1. Now, so what you have to realize is that all of the ions ended with a noble gas configuration. Okay. For the metals in 3, 4, and 5A, which we consider, when I talk about nomenclature, I call these the pluses of transition plus. Okay. So indium is in 3A, but it's below that. Even though aluminum is in 3A, you notice if it's below the transition elements, or equal with the transition elements. Actually, it's below. And so it has still 3 valence electrons. So it could either become indium 3+, which means it lost both the 5s2 and the 5p1, or it can become indium with a +1, and this one lost the 5p1. And so the 410 is considered to be the pseudo-noble gas. Okay, and so this is going to be the most stable here. 10, which is in 4A, this is a valence electron, and those are the valence electrons. So it can lose all 4 electrons, and so this lost the 5s2 and the 5p2, or it can lose 2 electrons. In this case, it lost the 5p2, and that's why these elements have more than one charge to them. And these are the nonmetals. So the anions from 5 to 7A is the group number -8 or -18, depending on which periodic table you use. And so these want to gain electrons, and so they gain electrons to become a P6. Okay, and so phosphorus has a P3, so it needs 3 more to get P6, and so it becomes a 3-. Sulfur has a 4, so it needs 2 more to become 6, so it becomes a sulfur 2-. For the polyatomic ions, they're covalently bonded. This is sulfate here with a 2- charge. For the transition elements, they tend to lose their s electron first, so that's why most of them have a +2 charge, but then they can lose 1 or more of the d electrons. So the example I have here is iron. Okay, so this is the electron configuration of iron. Iron has 2 common ions. The first one is iron 2+, in which it lost the s2. So this one lost the 4s2. And this one is the 3+, in which it lost the 4s2, and it lost 1 3d to become a half-filled shell, which has some stability to it. So this question asks for the electron configurations of 10 and 10-2+. So 10 is right here. It is a metal, so it's going to be a cation. but it's in group 14. So this has, and so if I look at the electron configuration, it's, so for 10, it's got a krypton, and then 5s2, 4d10, and then it's the 5p2. And so it wants to know what does it become with the SN2 plus. So SN2 plus is still going to have krypton. And so basically I'm looking at this one and which two did it lose? It's going to lose these 5p. So it's going to be 5s2, 4d10. And that's the SN2 plus. This one's asking for copper and copper 2 plus. So I'm going to go for copper plus and copper 2 plus, sorry. And so copper is right here on the periodic table. Okay. And so as such, its noble gas is argon. So I'm going to do copper first, even though it doesn't ask for copper. So copper is argon. And then starting here, this is 4s2. And 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we've learned in the last chapter that this is an exception. So this is not what it is. It's argon with a 4s1 and 3d10. So what has happened is that it has promoted that electron from the s to the d. So the copper 1, copper with a plus 1, is going to have lost this 4s. So it's still going to be argon and then 3d10. And copper 2 plus, it has to lose one more, so it's going to become argon 3d9. Okay, and that is the end of this video.